Welcome back. We're in section 4.8. We're looking at bearings and trigonometry today. Now in survey and navigation, the direction is given in terms of a bearing. Now a bearing measures the acute angle, so they're always acute, and it's the path or the line of sight makes with a fixed north-south line. So we say something is east or west of the north line or of the south line. So if we look at the first diagram, the way we would read that is 35 degrees to the east of the south line. So to the east of south. Now to make it easier to write, we would write it as south, S, 35 degrees east. That's how that would be written. Gives you the direction, north-south, the degree, and then east or west. So if we're looking at the next one, it's 80 degrees to the west of north this time. So that would be 80 in the middle, north first, and then west second. And now for the last one, we're 45 degrees to the east of north. So you would read that as north, 45 degrees east. So we're going north and then 45 degrees to the east. So north-south goes first, east-west goes at the end. Here is a word problem dealing with these. A ship leaves port at noon. So it's starting here, let's say. It's heading due west. So it's going to the west 20 knots or 20 miles per hour. Now at 2 p.m., the ship changes course to north 54 degrees west. So north, south, east, west. It's going to be turning and going in this direction. We want to find out where this ship is at and the bearings from that port of departure. So from our start to our end, we want to find the total distance, and we want to find out, how far it is from the port and the angle that it went at, its bearings from where it started. So now we have to think about the distances we went. It's traveling 20 miles per hour for 2 hours. So 20 times 2 is 40. So when 40 nautical miles there. So from A to B, it went 40 nautical miles. Then it traveled for 1 hour in that direction. So this segment here is 20 nautical miles. Our goal is to find this distance and to find this angle theta. Now this distance, we'll call it something in a moment. Now that's not a right triangle, but if I draw a horizontal and vertical and connect them, now it's a right triangle. So this is our endpoint, we'll call it D. We'll call this C. So here is segment D and segment B. Excuse me, it should be lowercase. Now, this picture is pretty cluttered, so I'm going to clean this up a little bit. I'm just going to be focusing on that small right triangle that we actually don't even really have anything for. Here's point C, B, and D. Now we know that the hypotenuse is 20, and we need to find the other two lengths. Now, all we have is the hypotenuse. And we actually do know something. This was 54 degrees. Having trouble drawing today. This angle from here to here is 54 degrees. So if that angle is 54, 90 minus 54 is 36. So 36 is down here. And then this angle up here would be 54 degrees. Sorry, because that angle the north 54 degrees west was right there. So now we do have some information. So we can find the missing sides. We'll call this D and we'll call this B. So we can use sine. So the sine of 36 equals opposite, which is B over the hypotenuse, which is 20. So B equals 20 sine 36. So B is about 11.76, and that's nautical miles. And then we can do sine of 54, and that's going to equal D over 20. So D equals 20 sine 54. D equals about 16.18 nautical miles. So now I'm going to draw the biggest triangle again. Here's C, here's A, and here's D. We know this distance here, this vertical distance, is 16.18. We know that this distance down here is going to be 11.76 plus 40, which is 51 point. I'm sorry, looked at the wrong one. Excuse me, flipped them. This one is 11.76, and down here it's 16.18 plus 40, so it's going to be 56.18 down there. This is a right angle, and we're going to find this missing side length. We can call it C. That'll give us our distance, and we can do that by using the Pythagorean Theorem. 11.76 squared plus 56.18 squared equals C squared. And then we know we're just going to take the square root of both sides. So C equals, so I'm just going to use my calculator. When I do that, I'm going to get about 57.4 nautical miles. So this, it traveled 57.4 nautical miles from the port if we were to measure directly. Now, what we can do next is we have to find theta. We need to find the angle that that boat traveled. Now, if we look at this part of the diagram, see how that's 54? This is 90. Excuse me, let's start that over again. We don't even need to do that. We can find theta by looking at this triangle that we already have. Because we have the opposite and we have the adjacent. We can use tangent. The tangent of theta equals opposite 11.76 over 56.18. So theta equals, so we're going to take the inverse tangent of both sides. Tangent inverse and tangent inverse. So theta equals the tangent inverse of 11.76 over 56.18. So that's going to tell us that theta equals 11.82 degrees. Now, it'd be great if we were just finding theta, but we're finding the bearings, so we've added a little bit of difficulty here. With bearings, we're looking at from the north or from the south. So what we're looking for this is an angle up here. Now, this is what we just found. This is the 11.82 degrees. We want to find this value here. So we just do 90 minus 11.82, which is 78.12. 78.18, excuse me. So 78.18 degrees. So our bearings, this is north and this is west. We're going north 78.18 8 degrees to the west is our bearing, and our distance is about 57.4 nautical miles from the port. So if we were to go directly, that's what we would be doing. But we did have the turns in there and everything. Okay, that is bearings and finding distances. Thank you, and I'll see you in the next one.